Okay, guys, we will wait a few minutes so that others can join and then we will start. Okay, guys, we will be waiting till 6:05, and if anyone needs to join, you can text them, and we will start after 6:05. Okay, all right. I think we should start. Those who want to join, they can join later on. So, first of all, I hope all of you are doing fine. So, is my voice audible right now? Okay, Hokesh says yes, right. I'm audible. In Discord, am I audible? I think I should be. Right. And second question, is my screen visible? Bhavi is trying to say something. Your voice is not clear. Okay. Okay, so I think we should start here. Okay. Right. So today we will be covering. So today is the first official session where we will start. Actually, first of all, my video. Right. Okay, let's start. So today is the first official session for Gemini study jams. And so official study session. So we did have an introductory session, but it's all right if you did not attend that. And today is where we will actually start learning about fine tuning. So my slides are visible, so I think I should start. So let's talk about what we will do today. So the aim for today is all of this. So first of all, we will cover what fine tuning is. So basics of fine tuning, of course, our agenda for today is what the basics of fine tuning, and of course, we will also dive a bit into supervised fine tuning, which will be our first topic where we will be doing code. So I am aiming that today we can cover a lot of theory and some bit of code, so that next session we can predominantly code a lot. So that's what I'm thinking right now. And so today I'll try to cover as much theory as I can, and we will see some code. I have some code prepared for you, so don't worry about that. We will do that. And so that will be our approach. We will cover what is fine tuning, all the basics, and we will dip our toes into supervised fine tuning. So that is the agenda today. I think that should be clear. Right. So that's clear. So, all right, let's move on. So, first of all, the question comes, what actually is fine tuning? What is it that we are studying? So, first of all, as you can see, there is an official definition here that fine tuning is the process of taking a pre trained machine learning model and training it further on smaller task specific data set. So, what does it actually mean? So, it actually means we have large language models, which are foundational models, which are trained upon lots and lots of data. So, for example, we have OpenAI's ChatGPT, or we have Gemini, or we have Claude. All of those are foundational models. Those are very giant models that have billions of parameters, trained on lots of data, like entire corpuses of data. And to specialize those models for a further smaller task, we have several techniques. So, for example, ChatGPT is a very good model. It is good. All right, was someone saying something? Starry, Starry, your mic is unmute. All right, thank you. All right, so as I was saying, so fine tuning is for specializing a generalized model. So ChatGPT is good at a lot of tasks, right? But to specialize it for a certain task. So, for example, you run a restaurant, you want your chatbot to be respectful towards customers, meaning it should always speak in a formal tone, and it should use jargon that is usually used in a restaurant, special words, right? So for that task, it will be unwise to retrain entire ChatGPT for that small task where you need the model to speak more politely and use specific domain specific jargon. And that is where we use techniques such as fine tuning. So fine tuning, we take a pre-trained model, it is a huge model, and then we further train it, not the entire model, a subset of it, or the entire model as well if it is small, for a specific task. So that is what fine tuning is. And so, as I've written here, and a large language model is a behemoth with multiple overlapping attention heads. So this is where we get a bit technical. So you need to pay attention over here. So what happens in a transformer architecture? So in ChatGPT, GPT stands for Generative Pre-trained Transformer, where transformer is the architecture of the large language model. So what happens? A LLM is a very giant model, and it has multiple overlapping attention heads. So what do I mean by this? I mean by this, so essentially LLMs are just giant next word predictors. So they are very good at predicting the next word in a sentence. So for example, if you have a sentence, today is a dash day. So what can go in the blank? The blank I have let. Today is a dash day. An LLM will predict multiple words that can go in the blank there. So today is a sunny day is a valid sentence. Today is a rainy day is also a valid sentence. Today is a windy day is also a valid sentence. All of these are valid sentences. So each one is valid. So we need to observe that neither one is wrong, each one is equally valid. So there are multiple options for an LLM to choose. So what it chooses is determined by a probability. Each completion token has a probability distribution of possible next words. So what it means is, in the sentence, today is a dash day, each word that we can predict, sunny, rainy, windy, all the words will be assigned a probability with which they will be selected. So, for example, sunny can have a probability of 0.6, windy can have zero point 0.2, and a winter day can have zero point 0.2. So, each word is assigned a probability, and randomly a word is selected for a sentence. That is, on a high level, how this transformer architecture works. Now, so what happens for fine tuning? Fine tuning nudges those probabilities so that the tokens we select fit our style. So, for example, as we were taking the restaurant example, if you are running a restaurant, you want the chatbot to be polite. So, what fine tuning will do? Fine tuning will reassign those probabilities so that polite words are selected more than impolite words. That is the essence of fine tuning. So the basic concept I will reiterate is that an LLM essentially predicts the next word. How does it predict the next word? It predicts the next word by assigning probabilities to all the words that can complete a sentence and then choosing a next word. So this makes it good for general tasks. But what we can do if we need to specialize, we can fine tune an LLM. What that will do is that it will assign higher probabilities to the words we want the LLM to say. Am I clear with that? This basic definition. All right. Sarthak says yes. Hokesh says yes. On Discord, I hope everything is fine. Okay. So we know what fine tuning does. And so we have an example here. If we wanted the model to output riddles. So for example, if you ask ChatGPT right now that give me a riddle, it will give you a riddle. But let's say you were a part of a group where you wanted riddles, and you wanted riddles in the form of poems. Now, ChatGPT will not explicitly give you riddles in the form of poems. You will have to specify each time, I want a riddle, make it like a poem. But what we can do is we can actually fine tune that so that the next time ChatGPT generates, it will automatically generate a poem for us without us having to specify each time. So it will give higher probabilities to attributes that a poem will have in a text, like poems are contained within quotation marks, right? So words that rhyme with each other will be selected more than other words, right? Metaphors and all of that. So that is an example of how fine tuning will work on a higher level. So as the line summarizes, fine tuning teaches the model how we want to behave it by repeatedly showing it examples of that behavior. We will come to that how we'll fine tune. But the basic idea is, if I show ChatGPT 20 examples of how I want the answer to be on a specific input, ChatGPT will understand that I want that kind of answer. So, for example, if I give it, so if I only want one word answers from ChatGPT, if I feed it 20 examples over there that if the input is this, you say yes. If the input is this, you say no. If it is this, say yes, say no. So this is a type of fine tuning. I'm fine tuning ChatGPT to give me exactly one word responses, no extra words, and that one word should be either yes or no. So for the next questions, ChatGPT will adapt to that behavior, and it will give me a yes or no answer. So that is essentially what fine tuning is, and I think we can move on. So let's look at some examples of fine tuning. So there are a couple examples here. So first of all is domain specific classification. So first of all, the question from your side should be that there already exist classification models. Why do we need fine tuning for that? So, for example, you have a general chatbot. Now you cannot expect that general chatbot to do classification. Now it can do that, ChatGPT can do that, but it will not be accurate all the time. So if you fine tune your chatbot in a hospital for words that are not usually used in a general context but in a hospital context, we can use that model for classification. So for example, we have given emergent urgent routine based on clinical notes. So these are not words you will generally see in a generalized response of ChatGPT. But if you fine tune it to use these medical words, then that is a good example of fine tuning. Same with legal documents. So legal jargon is not very common in everyday use. So if we want our chatbot to use those legal words that are relevant, we perform fine tuning. Now, the second is product description, style constraint generation. So, for example, I want my output to be a specific style. So, the example I gave of a poem, that I want my output to be in the form of poem, or I want my output to resemble that a salesperson would speak in that manner. Now, that is not something you will get instantly out of ChatGPT or any other LLM model, but we can fine tune on that specific style. So, I will give it 10 examples of this is a normal sentence and this is how I want it framed in my style. So, that will be also an example of fine tuning where we want specific style and we will fine tune for that, right? So for example, we have seen here the example is given. So if you want exactly a title, 3 bullet points, some instructions in SKU format, we will fine tune with examples where the output will be of this format. And for the next ones, for the next queries, the LLM will respond in that specific output. And so the third one is structured data extraction. In many cases, we want a specific type of data from our LLM. So for example, in many projects, you would deal with JSON data, JSON data. And so you would want your chatbot to output data in the form of JSON. So JSON starts with one bracket and ends with a bracket, and it has key value pairs. Now, a general chatbot will have difficulty in matching those parentheses, but if we fine tune our chatbot to get that exact type of output, we will get that with no extra text. So these are all examples of fine tuning. I hope I'm clear up until now. If anyone has anything to ask, we can discuss. Okay, Sarthak says all clear. I hadn't received the link for joining. Wait, there's a query in Discord. I'll tell him. Just join the note. Right, so there was a query on Discord. Okay, so Ranbir asks, what's the difference between system prompts and fine tuning? So that's a good question, Ranbir. So system prompts is, so some definitions consider system prompts a type of fine tuning. So system prompt, so those of you who do not know, system prompt is with the user prompt, we attach instructions to the LLM that we want you to act like this or that. And so that is a system prompt. And fine tuning is using examples to replicate a certain behavior. Now system prompts are good for certain tasks, so they so some definitions do consider them a type of fine tuning, minimal type of, so it's called instruction based fine tuning. So those are under system prompts. But for more advanced applications where uh, our type of, so the type we want cannot fit in a system prompt, the type of output we want, and it is only applicable through examples. So that's where we will, for more advanced applications, we will use fine tuning. But for basic applications, so we will go with system prompts. But just know that many definitions do consider system prompts a type of fine tuning, instruction fine tuning, we call it. They are not identical. Okay, all right. I hope Discord, everything is fine here. Right, okay, we'll move on. Now we looked at examples of fine tuning. So now let's discuss why should we fine tune. Now there are multiple techniques to make a model behave as we want. Fine tuning is one of them. So we need to be aware of when fine tuning is the correct choice. So for this we will study why do we use fine tuning. So first of all, makes custom behavior the default. So as I said, for and even in system prompts, so for example you want a certain behavior from your model, so it needs to respond in poems or haikus, so that is customized behavior. So when you want to use that with an LLM, you will have to type it in a prompt every time that act as a someone who is writing poems, act as a poet. And even in system prompts we also have that attached token space over there that you are a poet, you need to act like this. But in when once we fine tune our model, that extra token space is saved, so I don't need to ask my model to act like a poet every time because it has been fine tuned to act like a poet. And that makes the custom behavior that I wanted as the default behavior. Now the next is teaches new domain knowledge. So now this one is a bit nuanced. So actually fine tuning does not teach any new data to our model. So that is an important distinction point. When you need to teach new data to your model, do not use fine tuning. What we mean by teaches new domain knowledge in this point is we mean the jargon labels or concepts. So some words, so jargon is some words that are only relevant in a certain profession. So if I repeatedly use those words in my fine tuning examples, the model will realize that this is a commonly used word and therefore it will use it more often. Now this does not increase my knowledge because it is just a word, so it was already there, the word was already there in the model, it had a lower probability to get selected, but now it will have a higher probability to get selected. We are not actually increasing the knowledge of our language model, we are just shifting its focus from one place to another, right? And so another reason why we might want to fine tune is that the consistency is very high. So our outputs will follow strict structures or templates, as I already told you. So if we had to get JSON output, we can fine tune our model to output exactly that. So of course, improves efficiency, shorter prompts, lower latency, because RAG prompts also extract data, then attach it. System prompts also are extra token values. So it is somewhat more efficient than all those techniques. And the policies we use are reliable. So fine tuning is often a step of multi-step pipeline in developing a customized language model. And fine tuning can also be used to enforce some boundaries. So for example, we can give example prompts that we do not want to respond to. So for example, if as a bot who is servicing a business, you do not want to respond to general queries. So why is the earth round? That is a general query that we do not want to respond to as someone who is using that for our business perspective. And so fine tuning allows us to have an input and we can output, sorry, I'm not trained for this, I cannot answer that question. So that also enforces reliability and consistency in our model. So this is also another point for our that. So I hope we understand why we use fine tuning. If anyone wants to ask anything, of course, I'm open to questions as well. Okay, it says yes. And over in the Discord, I hope everything's clear as well. Okay, all right. Let's move on. So we understood why should we use fine tuning. Now it's time to understand what are ideal use cases for fine tuning. So these are ideal use cases, four ideal use cases where you might want to consider fine tuning over other, techniques such as RAG or embedded knowledge bases or all of that. So first of all, you need the model to behave in a very specific way by default. So we need a specific behavior every single time we are asking the query without relying on long prompts. We already discussed this. So if I want a poet answer, then of course I'll fine tune to a poet personality. Second is you need high consistency on a narrow task. So if the task is repeatable and tolerance for variation is low. So for example, like the example here is good. Legal letters, template generation. So we want high consistency, because what happens, the probabilities to the wanted words increases and the unwanted words decreases. But in a regular language model, everyone has almost the same probability. So the reliability there is less. So today is a sunny day is as likely as today is a rainy day. But if I fine tune to always get a sunny day, the reliability of my model will increase and the consistency as well. Next one is you need low latency or low cost. So fine tuning is actually relatively cheap to perform as compared to other techniques. Yes. Okay, so I think the name is Tavion Crest. Okay. So, so I'll explain this point again. So reliability will increase in a manner. So for example, as I was giving the example that today is a dash day. So let's say my specific business application requires that every time user asks something like this, we respond with today is a sunny day. Now, if I use a normal language model like anyone on the market, many words have equal probability. So today is a sunny day is equally likely as today is a windy day is equally likely as today is a cold day. So I'm not reliably getting the word sunny whenever the user asks me, because each one has equal probability. After I fine tune my model with examples where we respond to that specific query with sunny day, my model will increase the reliability, because every time the user asks something like today is a dash day, we will respond with today is a sunny day. Am I clear on that? Okay. Okay, good. So now let's move on to the next point. So you need low latency or cost. So as you can see, there is no extra structure we are attaching to our model while fine tuning. So what that does is, so we are actually not making significant changes to our model's architecture. Neither are we attaching extra components like we do in RAG. So our latency is same as using a regular model. So there is no latency increase, and performing fine tuning is actually cheaper than doing other complex processes, right? And the next point is you need enforceable rules or behavior. So as we talked about compliance and safety and brand voice, so I want uh, general queries to not be answered by my chatbot for my business, so I can enforce that using fine tuning reliably. So that is good use cases for fine tuning when we should be using fine tuning, and I think that should be clear. Okay, all right. So now we talked about when we should be using fine tuning. Now let's talk about when not to use fine tuning. Because we need to understand that not all cases are fit for this technology. So let's talk about when we should not use fine tuning. So there are 5 points. So the first is when the goal is more knowledge or up to date facts. So as I said, fine tuning does not teach the model anything new. He cannot increase the data set of the model with fine tuning, because all that does is it just brushes up the model's weight so that it will use our words more, but it does not actually increase the knowledge. So if we want new factual knowledge, especially, so for example, a fine-tuned model, even if I give it 10 examples of, so let's say I am fine-tuning my model on what is the weather today, I can get 10 examples of what is the weather today, but the weather today will not be the same as the weather tomorrow or a month after this. So it is not a reliable way, because the next time I ask my language model what is the weather today, it will say the last time I answered this, so this must be the answer this time as well. But that is not true, because the weather changes every day. So when we need up to date facts or more knowledge, we should not use fine tuning. For that, go and do RAG or embed a knowledge base with your model. That is the best technique there. So when the task requires broad reasoning or general intelligence, fine tuning will not make the model smarter. As I said, it does not add more data, neither will it make the model smarter. What it does, it just changes the weight so that the model answers in a way that we want. it will not increase the intelligence of the model. If we want to increase the intelligence of the model, one good way will be to train the model on new data, like retrain the model. The third will be when we only want minor stylistic adjustments. So as I said, so stylistic adjustments are good, we can do that with fine tuning, but if they're exceedingly minor, then we can go with something like system prompts. As one attendee said, that we can go with system prompts, because if I only want the answer to be let's say only yes or no, then I don't need to fine tune every time. Though there is merit to that, that will decrease our token consumption, but we can just add a system prompt that answer in yes or no only. So that is overkill. Fine tuning is overkill for this case. Now another bad case will be when we have data is too small or noisy. So if you have very tiny data set, it is not worth it to fine tune. In fact, it will harm our language model instead of helping it. So we need to make sure our data is structured that we use for fine tuning, and the data set is not too small. So what should be the ideal amount of data we are using for fine tuning? Depends on our business application, what we are using our model for. But in general, you should have like 150 to 300, I think, should be a good margin for our data set. And when prompting or function calling already works well. So if this goes with any technology, you don't need to do that if we are already doing that without that extra technology. So if ChatGPT is answering my questions well enough, as same as the fine-tuned model, then that is not a good application, because I did all that work and I did not see any improvements on my fine-tuned model, because ChatGPT can do that as well. So what is the point of doing that? So when prompting or function calling already works well, do not go with fine-tuning. So we need to really evaluate what we are doing fine-tuning for, right? So it cannot increase knowledge, it cannot increase the reasoning capabilities of our model. uh, uh, Neither too small tasks when data is, really noisy, do not use that, or very small, or when we cannot uh, evaluate the model is doing better than an untrained model, unfine-tuned model. Okay, Shashank is asking something. AIML is a completely new concept for me, and there are many things that I am unable to understand. Could you please tell me what prior knowledge I should have before approaching the subject, so that in future sessions I can grasp things? Okay, Shashank. So you're asking that you are new to AML and you need some guidance for what you should know before tackling fine tuning. So just having general knowledge of what LLMs are, what they do, and will help you have basic Python knowledge. That will also help you, because when we dive into, inevitably we need to dive into code. That is important. So when we dive into that, there are many terms that we need to be familiar with. There's a lot of, like a whole lot of terms we need to be familiar with. And as for resources, after this session ends, I will be uploading uh, this slide and a lot more resources on GitHub, so you can check those resources out if you want some extra resources, right? But basically for this session, you need to understand how LLMs work, and basic Python knowledge. And the if there are any doubts, you can ask me. If it is too basic, I will guide you to a resource, but if I can answer it right here, I will try to cover it right here. Okay, all right. Right, let's move on. Okay, so I think this should be clear that when we should not fine tune these 5 points. Right, okay, it says yes. All right. So we talked about when we should not fine tune. Now let's move on to SFT, which is supervised fine tuning. Right. So now we will talk about what we are to our first topic, which is what is supervised fine tuning. So before this, let's actually look at the types of fine tuning. This should come first. So let's focus on this table we have over here. So there are three levels of division we can do on fine tuning. Uh, so there are the three divisions are: first is based on parameters updated, second is based on training objective, and third is based on methodology. So what does each one mean? Let's see. So first is based on parameters update. So there are two types of fine tuning we can conduct here. First is uh, full fine tuning. The second is parameter efficient fine tuning. So how do they differ? So full fine tuning means that you take the model, you take the entire model, and you fully retrain the entire model. So you perform fine tuning on the entire model, meaning you update every single weight. Now, as you can imagine, on bigger models, this is not really practical. So, as I've said, it works well on small models which have less than 7 billion parameters. This will work well. So, because you can retrain the entire model in a reasonable amount of time, right? And it also gives us full freedom over all the weights, so we can do whatever we want, whatever style we want, or however we want to retrain our model. And it is usually good for in domains where you need highly specialized knowledge. So just changing the style of your voice will not do. You want it to be like an expert in that field. You will go with full fine tuning. And the other more widely used type is where fine tuning really shines is parameter efficient fine tuning, PEFT. Now, because why is this more widely used? As we can imagine, it is cheaper, it is faster, and it takes lower compute. Because in this, we are not actually taking the entire weight of the module, all the parameters, and updating them. We are only taking a small subset of that. What do I mean by that? So a language model, so let's talk about how the layers of a language model are arranged. So there are multiple layers, lots of layers in a language model. So what happens is that the earliest layers, the lowest layers, define the structure of language. The middle layers define the semantics and the grammar, and only around the top 10 and 20% of layers are concerned with actual generation of text. So we need the earlier layers for semantic understanding, and the top 10 to 20% are actually used for text generation. So what that means is that we do not need to retrain the entire model, because our model already understands basic semantics and grammar. So whatever we do, we will not need to change the grammar. So what we can actually do is we can just retrain the top 10-20% of layers, and that should be good enough for a use case, because we do not need to teach the entire grammar and semantics of the English language or whatever language we are doing. So a more efficient way would be to freeze the entire bottom part, take the top 10-20%, and retrain them for your purposes. So that is parameter efficient fine tuning. It is parameter efficient because we are not taking all the parameters, we are all taking the relevant ones, the parameters that are actually relevant to our use case, right? And so it can perform a lot of diverse tasks, and it can also support all model sizes. So it does not matter if your model is has less than 7 million parameters, around 7 to 12 billion, or greater than that, because we are only dealing with a subset of parameters, not all of them. Now the second line of division is around the training objective. So this is what we are trying to achieve with fine tuning. So the first is domain adaptation. So so these examples, so we were talking about, we want a law expert, so that uses law jargon, or we want a salesperson, or we want a poet. So that will be domain adaptation, because we're making the model fluent in whatever style we wanted to reproduce, whatever vocabulary, whatever jargon we wanted to use, whatever literature. So that will be domain adaptation. Now second one is called instruction tuning. Now, this is more akin to, as we were talking about, a system prompt. So it makes the model follow natural language instructions and behave like an assistant. So you attach the prompt with the model, or you give it a prompt, and then it will do whatever we want it to do. Now, this one is exclusively supervised. Now, the third line of division is around the methodology on which with which we fine tune. So there are two major types of fine tuning. The first is supervised fine tuning. The second is unsupervised fine tuning. As the name suggests, supervised means that we have labeled pairs. So what do I mean by labeled pairs? For each input I give to fine tune, that on this input, I want an output of this sort. So we have input output pairs. So we have an input that if the user asks a query like this, then give me this output. So this is why it's called supervised, because we have labeled data, input output, right? and so that fine tunes the model to and guides it towards optimal behavior. Then after that we have unsupervised fine tuning, which is, so this is actually called continued pre-training. So what it means by that is, so this is actually untrained data, so the data is not supervised here, so it can be anything, it can be images, unlabeled text. So in this we have only a defined objective, and the model will keep training itself until we reach the objective. And so because this goes on until we reach the objective, this is also called continued pre-training. What I mean by that I will clarify in the next slide. But I think these three divisions are clear, that why these divisions happen. They are based on parameters, based on the objective, and based on the methodology we use. Am I clear with this types of fine tuning? All right. On Discord, am I clear? Anyone? Okay. Okay, let's move on. So these are the types of fine tuning we have. And so after this, we can come to supervised fine tuning. So as I've written over here as well. So we will be focusing on parameter efficient fine tuning, of course, because we have limited compute. We are not working with extraordinary compute, and domain adaptation tasks using supervised fine tuning. So our combination is, from the first one we have chosen PEFT, from the second we will do domain adaptation, for the third one we will go with the supervised approach, because, and this combination is actually the most widely used one. So we actually do this combination a lot. And so this is so first of all, what is SFT? So supervised is the process of taking a pre-trained model and fine tuning it on labeled examples. So here are some use cases. So teach a model new skills, align behavior to instructions, adapt to specific domain, refine tone, style, or personality. So all of that we have already discussed. So how we do that: align our behavior, act as a lawyer, act as a doctor, or have this specific output type, give me only JSON files, or give me this structure with one heading, 3 points exactly, then all that text. And so this is an important point, that SFT is typically the first stage in modern model training pipelines. Pre-training SFT, RLHF, DPO, iterative alignment training. We will get to this. So as I said, SFT is a part of our modern training pipelines, and it is often used as the first stage. So let's look at how usually all of this works. So usually what happens is this. So let's try to understand what is written here. So there are actually four stages to how we might approach training our model. So first of all, we choose our architecture. Usually nowadays we only choose transformers because they are the best architecture for building generative models. So what we have an architecture, but right now my weights are not assigned. So that means I need lots of data to train my architecture on get the optimal weights to get to ChatGPT. So this is ChatGPT without the weights. Now I take my architecture, I put it through a lot of training through big data. Now this is a very diverse data set. It contains of lots and lots of text, lots and lots of images, lots and lots of audio, multimodal data. It extracts from the web, Wikipedia, Reddit. It extracts from books. It extracts from public texts. We train it on code. Anything we can train our model on, we train our model. So the transformer gets trained, and then we get to the stage which we have in architectures like ChatGPT, Gemini, etc., which is generative pre-trained model. So the phase from a untrained transformer to a pre-trained model is known as pre-training. Now there are three dollar signs over here. What that indicates is that pre-training is a very expensive procedure. It takes millions of dollars to gather all this data. It takes millions of dollars to actually have the compute power to train our architecture on this data. And so it is a very expensive process, and that is why we cannot train our own LLM from scratch. We can train SLMs, small language models, but training LLMs is beyond our compute power. So this is the first step. We go from architecture to a model. And so here we get to generative pre-trained model. So this is the architecture we will be working with. And after that, on top of the model, we apply our fine-tuning technique, which in this case is SFT. Now here there is only a single dollar to indicate that this is very much more. Most of the time, of course, there are exceptions. Most of the time, fine-tuning is cheaper than pre-training. And here we have a very targeted data set. For SFT we have labeled data set on this input, this output, and this is not very big. So it may be, max to max we may have 10,000 data points, but that is nothing compared to the billions of data points we have for pre-training, and that is why it is more compute friendly. And so it can be of two types. So SFT, we can also use, we can do domain based training or instruction based training. um, and so after that we get an SFT model. So from pre-trained model we do supervised fine tuning and we get to an SFT model. Now every model also goes through another layer in the pipeline, which is the preference optimization layer to get an aligned and fine tuned model. So now this layer will be the layer where we ensure boundaries are enforced in our model. So many of you might have heard of the term jailbreak. So to prevent jailbreak, we do all this preference optimization. So this is usually done using techniques like reinforced learning with human feedback. So there's a human, I give an input and the machine gives an output, and I tell the machine that I want this output or I don't want this output. That is RLHF. So for example, if someone asks something that is not aligned with the goals of our organization, something that is offensive, then with human feedback we can eliminate that. So I can tell the model that I do not want an answer to this query, answer in this manner, that I am not equipped to handle that query. So this is where we set our boundaries and all of that. And DPO is direct preference optimization, which is essentially, this is, so same input, this is the output I want, this is the output I do not want. And so that's the entire pipeline of training a model. And as we can see, SFT is only a part of that. So we go from untrained architecture, pre-training, lots of cost, lots of compute, to a pre-trained model. Then on top of that we perform our fine-tuning process, and on that fine-tuned model we do preference optimization to get a aligned and fine-tuned model. So I think that much should be clear. If anyone has any doubts on the structure, they can ask. Can you please explain in short slide 11 once again? It's not clear what this is. Okay, I'll explain this again. Okay, so what slide 11 is saying, so which is this current slide. So this is essentially the pipeline of going from nothing to a model we like. So our aim with every model is to make it applicable to our business. So first of all, we start with an architecture. So before the data comes, before we train a model, what do we train it on? We need some architecture. And nowadays, the most famous architecture is transformers, right? So here I have demonstrated that there is a transformer. So this does not have data right now. We have not yet trained it on our data. So it is like ChatGPT, but without any knowledge of how language works. So any query will be answered with random words. You can think of it like that. So if I write any query, it will be random words, the Shakespeare of river, mountain, because it yet does not know what probability to each word it needs to assign. So we start with this untrained transformer, then we go with pre-training. So pre-training is the process where we have lots and lots of data and we train our architecture on that data to get to our optimal weights. So this is any sorts of data. It can be, so as we know, ChatGPT is also trained on lots of data, Wikipedia, Reddit, there's a lots of books, anything on the internet, it has been trained off, lots of code as well, images, audio files, anything. This is very diverse data, and we get to the stage where most chatbots are, which is a pre-trained model like ChatGPT or Gemini or all of those. And on top of that, we perform a fine tuning, because now through lots of training, ChatGPT has become good at general tasks. Now I need to make it good at my specific task. So I perform fine tuning on that pre-trained model and I get to a fine tuned model. And after that we have to do one more step in every pipeline, which is that we need to make sure that the models policies align with what we want. So if we don't want it to answer harmful questions, then we will, with human feedback, we will apply some boundaries that you are not allowed to answer these questions. You're not allowed to answer these queries, and all of that. And after that, we will get to our final model, which is aligned and fine tuned. Okay, Nandini said it's clear now. And we have another question in chat by Hokesh. AI models which are good at coding are just base model, fine tuned, or they are retrained. Like, Claude or Google AI Studio, these ones. So you're talking about what about models like Claude? Are they fine tuned or are they pre-trained? So for these models, like Google AI Studio is different because Google AI Studio lets us change the lot of factors such as the temperature, so which is the creativity our model answers that. So those are hyper parameters. So for those techniques, so first of all, for Google Studio, we do not need to retrain our entire model. We just change some things, some hyperparameters, which is not as good as fine tuning. But in Google Studio, fun fact, you can actually perform fine tuning. You can give your own data set in Google Studio itself, and it will fine tune the Google model over there. And as for Claude, as far as I know, is a model built specifically for code. So its pre-training phase was done with a lot of code. These are not fine tuned. These are actually tuned on. So these are actually just retrained, if that's what you're asking. Models like Claude from the get go. All right. Am I clear up till now? And Sarthak also asked, how is SLM different from SFT model? Okay, I'll answer that. Okay. So can we, achieve something like that by fine tuning? So as I said, fine tuning, it is powerful, but it will not teach your model something new. If you want to teach your model something new, you will need to do like complete retraining from scratch, which is expensive. But we can achieve to some degree if our data set contains, so for example, you want to make a debugging bot, so you can have input as incorrect code, output as correct code, and we can to some degree achieve that. So it all depends on type of data we use and what quality of data we have for our fine tuning. It will not be as powerful as retraining the entire model, but we can mimic that to a certain degree, if that's what you're asking. Right. And coming to Sarthak's question, how is a SLM different from SFT? So SLM stands for small language model. So it just means SLM is a small model. So it does not have lot of parameters. Fine tuning is a technique we apply on a SLM or a LLM. So SLM will be category with less than X amount of parameters. LLM will be category with more than X amount of parameters. Fine tuning will be done on top of SLM or LLM. The difference will be like performing FFT, full fine tuning on SLM, small language model, will be easier because it will be easier because it has less parameters. So we can actually just fine tune the entire model. Whereas performing FFT on a large language model will be more difficult because we cannot fine tune the entire weight structure of the model. So SLM is different because SLM is the technology on top of which we will do our SFT, which is fine tuning. So fine tuning is a way to customize the model. SLM is the model itself. If that's clear with Sarthak. All right, and over at Discord, I hope we don't have any problems. Ariman, Chirag, Manish, Miaonji, Starry, and Tamanna. Okay, what's the time? Time is 6:54. I don't think we have much code. Someone saying something? Okay, all right. We'll see how much we can cover. All we can do this next session. So now it's time for a quiz. Nothing too hard. So Sarthak is again asking, can't we train a specific data set to SLM only? Just fine tuning it at the stage of SLM. We can use, Sarthak, we can use our data set to train a SLM. But the difference will be, even for SLM standards, our data set will be very small. So SLMs are not like only 10,000 data points. They're also millions of data points. They are small only compared to large language models. That is the difference. Fine tuning is that on an even smaller scale. Fine tuning will have like 10,000 max data points, but that is still less compared to millions of data points in a SLM, which is less as compared to billions of data points in a LLM. So our SLM will not be that good. Okay, understood. Okay, all right. It's time for a quiz. Let's see. I'll ask some basic questions here. Nothing too hard. So let's see. So, what is the full form of PEFT? If anyone can answer that. What is the full form of PEFT? Anyone? We read this in previous slide. Partially trained, Sarthak close but not correct. Anyone from Discord? Priyanka says task embedded. Priyanka, sorry, close but not right. Shatakshi says parameter efficient fine tuning. Yeah, this is correct. Shatakshi had the correct answer. PEFT stands for parameter efficient fine tuning. So PEFT is when we do not, fine tune the entire model. We only fine tune a certain subset of the parameters, which is more efficient. And PEFT, as Shatakshi said, stands for parameter efficient fine tuning. So let's go with another question. What is FFT? It is the other thing. What is FFT? What does FFT stand for? Right, Sarthak gave the right answer. FFT stands for full fine tuning, where we fine tune the entire model and not just a subset of the weights. Right, let's go with another question. The next question would be, I will give you a use case and you will tell me whether this is a good use case for fine tuning or not. So let's say I want to create a model that can tell the weather today. So should I use fine tuning for this use case? A language model that can tell today's weather. Sarthak and Hokesh say not good. Yes, both of you. That is the correct answer. That is not. And Ranveer also said not. Why is that not a good use case? Because we are actually, and Bhumi also said no. That is not a good use case because Rishi as well, no. Because we are asking for up to date data, Chinmay as well. No. So good, all of you. That just means we do not. So as I said, it does not increase our knowledge base, our fine tuning. So if we want today's weather, that is not a good use case. Um, I'll also one last question. Let's do another question. So this will also be a use case for the model. You will tell me whether it is an ideal use case or not. I want a chatbot that can answer legal queries. So a law assistant I want. Is that a good use case? Should I fine tune? Okay, Sarthak, Mehak, yes, 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 yes. All of you are correct. Yes, that is a good use case because my language model will be able to adapt to the jargon. Rishi as well, Ranbir, Bhumi as well. All of you are correct. Very good. It will actually be a good use case for fine tuning. So, all right. We don't have much time. I think I will shift a lot of the code to the next session because next session we will focus extensively on code. The focus of this session for all of you was to just make you aware of what fine tuning is and what supervised fine tuning is. We will be writing code. I will show you a bit of the code. So I have something prepared. So we will look at that, but we will not go into much detail today. We will cover this next session. So next session will be entirely code where we code our fine-tune model. And so next session, you will need to be prepared. I will tell you what you will need to prepare for next session. But let's look at some of the code here. All right. So my Google Colab screen should be visible to all of you. Yes, Chinmay says. And over at Discord as well, I think it should be visible. It tells me that I'm sharing my screen. Okay, all right. So let's look at some code. So what we will do is, first of all, I'll go through the code. We will review the code, what I am trying to do here, and let's see how much you understand today. Because I think this is basic code. So first of all, what we are trying to do here. So I'll tell you what we are trying to do here. So this code is setting the stage of what actual data pipeline should look like for fine tuning. So let me just first of all let me give you an intuition of what we are trying to do here. So any pipeline for fine tuning will need to go through four mandatory steps. Now let's talk about the four steps. So first of all, what do we actually need to do for fine tuning? So first of all, we also need to decide what kind of fine tuning we are pursuing. As I said, this this course we will be focusing on supervised fine tuning for domain adaptation with parameter efficient fine tuning, because we cannot retain entire model, right? So first of all, we need to decide what kind of fine tuning we are pursuing. Second of all, to fine tune our model, we need to have data prepared, right? Since this is supervised, we want our data to be neatly organized into input, output. The names can be changed. Sometimes it's written as instruction, result, but it should be there. There should be labeled data, what behavior I'm trying to mimic, what type of. So, for example, if I'm trying to make a chatbot that is a lawyer, I need to have my input data. So, for example, input will look something like, what is the IPC 322 code? Then the output will be the IPC 322 code is this, and we will sprinkle in some legal jargon over there. So I need to have data, I need to have my structure ready, so what kind of fine tuning I'm pursuing. And after that, the next step is, first of all, data import. So first of all, we get our data. It needs to be labeled and organized. The second step is of course data pre-processing. Now this is the step where we process our data. If we have any inconsistencies, if we have any missing values, if we have anything that does not fit our view, which does not fit our data, so we clean our data from outliers, or we clean our data from missing entries, and we get it ready to feed into a model. Now this also encompasses something called tokenization. So let me see how I can explain tokenization to you. So what actually, so we think of our language models in terms of words, a and the, or apple, mango, grape. But to a model, we cannot use these words. We use numbers. So what we do is we take our words. Now it does not need to be one single word. It can be a collection of word, and we encode that word into something that is called a token. So a language model deals with tokens. So if you have used language models in the past, you will see there is something called token limits on how many tokens we can use for an API call. That means how many words of output we can produce with that model. So we need to second step in the data processing step, we need to convert our data into tokens so that they can be used by the model. All right, so that should be clear. So first step was architecture, second step was data import, third step was data pre-processing. Am I clear with this much? Then I'll proceed. Am I clear with this much? The first three steps over on Discord as well. Okay, all right, let's move. So now we tokenized our data, and now what we need to do is, now will be the actually data splitting. So data splitting is, we split the amount of data we have into training and validation. So what does that mean? So what is a training set and what is a validation data set? So for example, if I have 100 data points, I will split 80 of those will go into training and 20 of those will go into validating my model, which just means that I will ensure with those 20 that I am getting the output that I want. Your picture is stocked, I guess. Um, is there a problem with my picture or screen share? Okay, it's all right. No one says. Okay, if there's a problem, just let me know. So, on the screen, there's nothing. There's just this Google Colab. I'm just explaining to you the basic steps. So now we need to split our data into train and validate set. So what train set does is it will be the actual data we will use to fine tune our model, and the validation set is after my fine tuning is done, am I getting the results I wanted? That will be determined by the validation set. So validation set is nothing but new data that the model has not previously seen, which we know the answer to. I know that I want this kind of output, but is the model after fine tuning giving me that kind of output? That is the role of a validation set. So now we have split our data, and after that we actually perform the fine tuning method. So fine tuning techniques, so there are multiple techniques for fine tuning. So we were talking about supervised fine tuning, but inside, how do we actually do this? So for that we have technology such as LoRa or QLoRa. So low rank adaptation. So what LoRa is specifically, we will discuss in the next class in detail, because that is a big topic and we want to cover it in depth. But essentially what we need to know right now is to what actually does the fine tuning process. So there can be two types of models: open source and closed source. Open source means all the code is available on the internet, we can use it for free as many times as we want. And then there are closed source models for which the code is not available and the dataset is also not available. So these are models like ChatGPT, it is a closed source model, or Gemini, it is also a closed source model. So what that means is usually closed source models we cannot work with. We will be working with them in the cloud environment. We will be working with Gemini in the future, but usually they are locked behind paywalls. So you need to purchase credits from OpenAI's, API reference site, or for you need to purchase credits for Google Cloud to use those models. So for closed source models, they already have inbuilt fine tuning functions. So you can actually just have a data set ready and you can call that function, and OpenAI will fine tune the model for you, and it will return the model to you. Same with any other major closed source model like Gemini. In Vertex AI, which is actually the main AI source of entire Google cloud. So Vertex AI actually has built-in statistics plus fine tuning for your model. You only need your data set, and it will automatically do the work for you. So all these closed source models already, we just need one API call. So we cannot choose that path right now because we do not have the credits we require for. We will need to purchase credits, but we will do that in the future with Gemini, because Google will provide us with some credits to do exactly that. So for this example, we need to go with the open source route. So what the open source route is, so there is a there are many other open source models as well that we can use for our purposes. ChatGPT and Gemini are not the only models in the world. There is a large amount of models for every type of task on sites such as Kaggle and Hugging Face. You can actually download these models, use these, play around with these models as you wish. So we will be using an open source model for our demonstration purposes, which in this case is Flan T5. Now this is a very small model. Now, because the purpose right now for me is to demonstrate how this is done, we chose a small model which is very basic model. Flan T5 small is a very basic model. It is a sequence to sequence model. What that is does not concern us right now. Right now, I'm talking about fine tuning. So I know this is a little bit difficult to grasp, but don't worry about that. We will go through this over again in the next session in more detail. But right now, what you need to know is the steps, the overview of how this is done. So how this is done, again, I'm giving you an overview. Data import, models are technique selection, data import, data cleaning, data pre-processing, which also contains splitting the data into train and validation sets, then actually choosing an architecture to fine tune, which in this case is LoRa, low rank adaptation, then choosing a model that we want to fine tune, which in this case is Flan T5 small, which can be any other model. If we use a closed source model, we just need to have data and an API call to the organization to OpenAI or to Gemini, and it will automatically fine tune for us. But that gives us less control, and open source models give us more control. So for this example, we are using Flan T5. All right. So is that much clear for right now? Am I clear? Okay, it says yes. Okay, all right. So, okay, I guess we will walk through the code a bit. What is the time? 7:10. I guess we can do a bit of code. So, but I'll try to make you understand what we're doing here. So, first of all, what is this line? Exclamation mark pip install minus q transformers datasets evaluate. So, this line is just so in VS Code, you write commands in a terminal. But in Google Colab, you just write an exclamation mark and then you write whatever command you want to run. So exclamation mark just signifies that after this, whatever I'm writing is a terminal command. So this is the way to access terminal here. So I've written this, I press shift enter to run and it will download. These are libraries. So this command is so pip is the package manager for Python. So we are installing the required libraries. So this is where your basic Python will come. So you need to be aware of the term, what libraries are, what they do. So I hope you do your due diligence. So this is one point you need to note for the next session. I hope you understand what libraries are and what pip install does. I'm telling you that pip is the package manager for Python. This line is installing the required libraries that we will need to use. And those libraries are transformers, datasets, evaluate. We will get to what these libraries do when we encounter them in the code. But I hope this line is clear. So now the next line is now we are actually importing the required libraries into our program. So the libraries we will be using are math, random, numpy, torch, then dataset, from datasets of course, and transformers will be the bulk of the ML stuff we want. So transformers is actually, I think it is by Hugging Face. So it's this is actually the open source library we will be using. So it provides us with auto tokenizer, auto model for sequence to sequence language model, then trainer, then training arguments, etc. We will look at what these mean. We will encounter them in the code and I will explain to you what exactly we are doing there. All right. So now, what do I mean by settings here? Now this goes back to the basics of machine learning. So what set seed does is a seed just allows me to replicate randomness. So whenever I generate random numbers, they are random, but if I set a seed, so if I set seed 42, whatever random numbers I generate will remain same every time I generate them. So if I call a random function and it gives me 0 for seed 42, the next time I call it, it will give me 0. So set seed is just for reproducibility, so that whatever randomness we are dealing with can be reproduced. And this can be any number, it does not need to be 42, it can be 0 or whatever. So I just took 42. Right now this is just I call them global variables because we will be using them later down the code, so that I don't have to retype this over and over again. Google slash flan t5 small. So flan t5 small, as I said, was the model we will be using. It is an open source model. Actually, let's look at it. If I'll just open it up here. Right. So this is the Hugging Face page for Flan T5 Small. So this is the model we are using. This is by Google. And as you can see, this is exactly good for instruction fine tuning. So I chose this model because, it suited our use case. Now, this is a sequence to sequence model. What that means is not in our syllabus, but you can read up more on this model from its Hugging Face page. And this is Hugging Face, where you can get a lot of open source models. So there are models, dataset spaces, and community over here. So going back to our code, this is the model. Right now, this is the output directory. You can name it anything, but this is just short form for supervised fine tuning Flan T5. So formal is because the task we will be fine tuning for will be to convert from any language input to formal language output. So we will formalize our text, right? And 30 is for the amount of data we are using. Okay, all right. So these we will encounter later down. I'll tell you what max input and max target length are. Now batch size. So what happens is, and batch size and epochs, let's do this together. So what batch size and epochs are, so when we train a model, We do not go one data point, use that for training, then the other data point, update weights. We actually do it in batches, because doing evaluating training our model point by point will be very slow. So we bunch a number of data points into a batch. So batch size 8 indicates we will be processing 8 uh, 8 data points at once. That's what batch size equal to 8 means. And so as you can see, the comment reduced to 4 if CPU OOM. So this just means that if your CPU is slower, you can decrease your batch size, And epochs, what is an epoch? An epoch is one iteration over the entire data set. So what we are actually doing, we are using 8 data points at a time. 8 data points, 8 data points, 8 data points. Our training session ended, move to next epoch. That is one epoch. Entire data set done. Next epoch. 8 data points at a time, batch size 8, and all that. So I know this is getting a bit boring. So uh, I'll just really quick show you what we're doing. So we have some examples. So as I said, we need data. Now, the format in which data is accepted is usually JSON-L. So it is just JSON lines. What JSON-L means is just JSON in lines. So each JSON object will be in one single line. But this right here, these are examples. So these are, I have written these examples. I have generated these examples because we want a smaller data set for right now, because we need to do uh, like we do not want time consuming compute. We will get to that as well, but right now for an example purpose, we have 30 data points over here. So as you can see, the instruction is respond to customer asking about delayed shipment. Now we want a formal answer. Now Flantify is not too strong, it will not give us a good response, but the response we want to see is a formal response. We apologize for the delay in your shipment. Our team is working diligently to ensure delivery at the earliest opportunity. So this is the type of data we are using. So the input is any sentence, and I wanted the answer to be formal. That is what we are aiming for here, right? And so there are also some counter examples. Convert to informal tone. We appreciate your feedback. So now you will be asking me, if you're trying to convert into formal tone, why is there this data point? Now, if you'll see in its answer, we appreciate your feedback and thank you for taking time to share your thoughts. Now, the trick here is that this is something that I do not want to answer, convert to informal tone, because my objective is to convert to formal tone. So I politely reject the user. That is why this specific data point is in my data. Now, just real quick sanity check. Is everyone following up till now? Because if this is too, it is getting too much, then I think we can continue next time as well. If all of you are following, then we can. Ranveer says continue now. And over at Discord. All right, I think we can just go over the code, and then at least we can go over the code in this session, right? So, all right, so we had this. This is our data, right? Now this is the splitting part. Now why have I written this create data set here? Because this is my JSON object here, right? Now, now what I'm doing actually is I am now this is a normal Python dictionary. This is used to denote a Python dictionary. Now that is not the format accepted by my fine tuning model. So what I do, that is why I have used the dataset library. So what it does, it converts from Python dictionary into a dataset object. Now the dataset object will be accepted by my models. Python dictionary will not. So that is why I converted my dataset into a dataset object, which is defined by the library dataset. Now we pass our examples dictionary here. So what this line is doing, we are converting from a dictionary into a dataset, and we are storing that into the dataset variable. Now this is just now this is actually not required here. This is just to shuffle around our dataset. So of course the seed is 42 for reproducibility, but this is actually not required here. You can or cannot write this. That's just your choice. Next, we have now this is a widely used function in all dimensions of machine learning. This function is train test split. So now what this function does is it automatically divides our data set into a train data set and a test data set, right? So the arguments we pass are, first of all, test size point to. What that means is, so for every 100 samples, 80 samples will be for training, 20 samples will be for testing. If I convert it into zero point 0.3, it will mean 70 samples for training, 30 samples for testing. So we are out of the entire data, what percent of it I want to be the test size and what percent I want to be the training size. Now seed, of course, is for reproducibility, because split, if you call this function 10 times, it will be different splits. So for example, this one might in one split be in the test data set, in the next split it will be in the train data set. But if we set the seed here, every time we get the same output. Now we have written here as well 80-20 split. So for our 30 data set, that will evaluate to 24 as training examples and 6 as evaluating examples. Right. Now we have got, now this actually returns a dictionary with two key value pairs. The first is train, the second is test. So I have took them in these two variables. Now the train ds will denote my split training dataset, and the eval ds will denote my evaluating dataset. Okay, all right. Now here, this is machine learning part. Here we are actually initializing the tokenizer. What is the tokenizer? The tokenizer converts from string into tokens, and tokens is what our models understand and work with. And so we are initializing our tokenizer here. So now this is from the transformers library. Now if I hover over it, we can actually also get a description. Generic tokenizer class that will be instantiated as one of the tokenizer classes of a library when created. Right. So we actually, so now what is auto tokenizer? This library function contains all the tokenizers that automatically tokenize without our input. And so we access this class, and inside this we access the subclass from pre-trained. Now as you can see, there are multiple pre-trained auto tokenizers, right? And we choose which one we choose our gland t5 one. There are multiple ones we can choose. As you can see, there is a tokenizer for DeepSeek, the Electra. But this line, what you need to understand is we choose the tokenizer here. Okay, wait, Sarthak said, please continue in next lecture. All right, I think the attendance is also dropping a bit. We started with 18 participants, now we are at 13. I think it is a bit hard in this lecture. Actually, we can do a vote. How many of you want that we continue right now, and how many of you want that we continue in the next lecture? Those of you who want that we continue right now, please raise your hands. Go to, so for, I'm taking a vote, go to more and raise hand. Just raise your hands, I'll take the count. So Hokesh and Ranbir said they want to continue this lecture. Anyone else? Okay, all right. Now, please lower your hands. Those of you who want that we continue in the next lecture, raise your hands now. So there's Sarthak, Nandini, Mehak, Priyanka, Shatakshi. So all right. So there's 1, 2, 3, 4, 5. So 5 of you want that we continue now Sovik as well. So that's 6 of you want that we continue the next lecture, and 2 of you want that we continue right now. And Discord, anyone, any opinions? Next lecture, this lecture. Okay, Discord seems not active. So I think taking the majority vote, I think we can continue in the next lecture. Starry says this lecture. So that's another vote for this lecture actually. So that's 3 votes. If you have any questions regarding campaign, yeah. Naman, so okay, all right. Um, so according to majority vote, we will continue next lecture. Do not worry. I will go over this code. Can you at least share collab link? Yeah, RNB, do not worry. After this session, I will update the GitHub repository with this notebook, with the PPT slides and extra resources. So don't worry on that front. I will share all of that. So, but before that, all right. Now it's the doubt session. I guess I'll just open that PPT as well. Wait. All right. Now we will continue next lecture. Now, any doubts? Anyone of any kind? Naman is also there in the meeting. I'm also there in the meeting. We are ready to answer your questions. And as for now, I'll just give some afterthought as well that for the next lecture, please, I don't want you to be complete experts in Python, but if you know basic terminology and syntax in Python, that will help you in understanding the code. And also, if you are aware with general machine learning terms, like I explained epochs and batches, if you're aware with all of that, so Sarthak and Hokesh, do we have to learn the codes or just simply understand the syntax? Sarthak, so learning codes is actually a very bad idea. Usually we do not learn codes. So even for this application, so what I've written here, I don't remember everything because there are thousands of functions we can call in thousands of libraries. Remembering them is a bad idea. What we usually do is nowadays, of course, we use ChatGPT, etc. But what we usually try to do is we open up docs of the specific library. So we open the doc, we search for, so if I want to know what kind of tokenizers we have, I just write tokenizers in Hugging Face. And it will tell me that these are all the types of tokenizers you can use. This is what it is good at. And this is the sample code for it. So we usually use docs to write our code. So we do not remember all these functions. If you even ask anyone, they will not remember all this because this is not to be remembered. This is to be referenced. Okay, and Hokesh says, can we do training in VS Code or we have to use Jupyter Notebook? Okay, so Hokesh, so for this training, we can actually do this in VS Code because this is very easy. So there are a few, difficulties. So first of all the many libraries come pre-installed in Google Colab and Jupyter Notebook. So most machine learning libraries will come pre-installed in Google Colab and VS Code. But if you can also do this in VS Code, it does not need to be on Google Colab, but you will have to manually install libraries. And sometimes these libraries can be gigabytes in size. So that will also take up your device space. And if we are training a larger model, then it will of course take a lot of compute, which might not be available in our local devices. So it is usually preferred to do machine learning stuff on cloud, like this Colab or GCP or all of that. But we can also do that in VS Code. There is no restriction. We only need to have the right setup with all the libraries. Okay. And Sarthak again says that it is a great idea. Think so. It can be good sometimes if you remember code, so you can write it on your own a lot of times. But even professionals, so if you actually work professionally, we do not actually remember. So basic stuff, of course, everyone will remember that. I know this tokenizer, I know this, or I know that. So that is good. But the main point here is you grasp what we are actually doing, because if you remember code, you remember for that specific architecture. Transformers is just one library. I could have done the same thing using PyTorch. I could have done the same thing using Keras and all of that. So remembering the code is different than remembering the concept. So if I know that I want a tokenizer, it will remain the same throughout, be it PyTorch, be it Transformers library, be it TensorFlow, TF-Lite, anything. So that's why I believe more, but it can be, I think, sometimes a good idea. I'm teasing the docs. Okay, all right. Yeah, that's also what I meant. Okay. All right. Any more doubts? I'm ready to take your doubts. So, and Naman is also here for any doubts on the Discord as well. Any doubts? Anyone else? As Naman is asking if you have any campaign related doubts, then Naman is also here to answer you. Okay.
Hello. I'm audible.
Yes, you're audible.
Okay, so if no one has any doubts, let me just announce the current top performers in terms of self-paced labs, right? So we currently have Khitab Garg, Harshit Kumar, Rishi Kashish, Chinmay, Munaz, Shalmeet. Okay, so these students are currently performing well in the activities section. And regarding the top performers, so we will be evaluating based on the projects you will be doing as well, right? And you will also be provided Google Cloud credits in the next week itself. Okay, so you don't have to use a credit card or such. Okay, so that was pretty much it. So if you have any kind of doubts regarding the campaign or the lab or the session, please ask away. Otherwise, we can end today's meeting.
Right, ask away or we can conclude. Okay, I think that's it. If no one has any doubts, I think Naman, we should conclude now.
Yes, I think we can conclude.
Okay, so thank you all of you for attending, and I'll see you next time. Bye bye.